Now, there are certain mistakes some of you make, all right, in Math 209, and I want to use this medium to correct it. Now, let's start by using a story, right? I said there was a time in a kingdom where these people, E inverse, and these people, they were existing, right? Now, I met one man on the road. He called this guy the forward difference operator. That's what he called him. I said, okay, no problem. And then he was telling me that the forward difference of f of x is f of x plus h minus f of x. I said, how? I said, sir, can you prove this? He said, if this is the number line, he said, and I call this place f of x, then definitely this place will be f of x plus h. This place will be f of x plus 2h as we approach infinity. I said, sir, could this be possible? He said, yes. He said, meanwhile, the h here is called interval of differencing. That's what he told me. He said the h there is called interval of differencing. I said, okay. I said, sir, so what would be f of x plus h? What would be the forward difference of f of x plus h? He then told me that this will be f of x plus 2h minus f of x plus h. Similarly, what we are simply saying is where we are going to minus where we are coming from. Let's not forget that. Where we are going to minus where we are coming from. I said, okay, sir, there's no problem. Then I said that, sir, what would this E operator mean? The E operator, what would it then mean? Then he told me that the E of f of x is simply f of x plus h. So what this E does is that it pushes f of x to the next person, from here to the next person. So he said that the E of f of x plus h is f of x plus 2h. So I'm simply just pushing it to the front. He then told me that having said this, he then said that there is a similarity or there is a relationship between forward difference and E operator. And then he said, how do we know this relationship? I said, okay. I said, since you have told me that the forward difference of f of x is f of x plus h minus f of x, and I can recall that you said the E of f of x is f of x plus h. Let me substitute this into this. It means that the forward difference of f of x is E of f of x minus f of x. I said, okay, no problem. I said, sir, what do we do from here? He then told me that we can factorize. And then I said, okay, so the forward difference of f of x is equal to f of x into bracket e minus 1. And so when we cancel out, we discover that the forward difference is equal to e minus 1. So this is an identity. So in your test question or your exam questions, you can be asked that prove this. Do you understand? You can be asked, they can tell you, prove the forward difference is equal to e minus 1. Is that clear? Now, having said that, in that same kingdom, the man met me and he was telling me that this guy is called the backward difference operator. Backward difference operator. And what he told me was quite funny. He said the backward difference of f of x. Now let's draw the number line just as we did for forward difference. Now if this is the number line and we call this place f of x, we call this place f of x plus h, we call this place f of x plus 2h, right? Now the backward difference of f of x means where we are going, where we are right now, where you are right now, minus what is at your back, minus what is at your back. Is that clear? So I don't want you to start making these mistakes again. Do you get it? So when we say the backward difference of f of x is where you are right now minus what is at your back. So because it is 0 that is at its back, we cannot start from the backward difference of f of x. Let's rather start from the backward difference of f of x plus h. So the backward difference of f of x plus h is f of x plus h minus f of x itself. Did you see that? Minus f of x itself. So we then began to find out that there is an operator called the E inverse operator. Just like the E operator pushes to the front, forward, the E inverse operator pushes backward. Did you see that? So when you say E inverse of f of x, so when you say something like this, E inverse of f of x plus h, you are simply saying go to the back. Remember, this is your number line, and this is f of x plus h, and this is f of x. So if I say, if I'm at this point and I say E inverse of f of x plus h, my answer is to go to the back. You understand? So E inverse is working here. But if I say f of x plus 2h and I say E of f of x plus 2h, my answer is to go to the front. So, having given that illustration, the man began to tell me that the E inverse of f of x plus h is f of x. Did you see that? And so from here, we now discovered that there is a relationship. There is a relationship between the backward difference operator and the E inverse operator. Is that clear? There is a relationship between the backward difference operator and the E inverse operator. What is the relationship? We said that remember, the backward difference of f of x plus h is f of x plus h minus f of x, right? And we recall that E inverse of f of x plus h is f of x itself, is f of x, right? So let's substitute. Did you see that? We began to do what? We began to substitute. So when you substitute that, you're gonna be having backward difference of f of x plus h is equal to f of x plus h, f of x plus h minus what? E inverse of f of x plus h. Did you see that? So what do we have? So we said that we can factorize. So this cancels this, cancels this. So backward difference is equal to 1 minus E inverse. Did you see that? They can ask you this question in your exam. This is another identity. They can say, prove that, did you see? Prove that the backward difference is equal to E minus E inverse. So that is that about that. Is that clear? Now, having said all of these things, I discovered that some of you make mistakes in the Newton-Raphson when we say finding the square root of a positive integer n. Many of you make mistakes here. You make a lot of mistakes. Now, remember that when you have the Raphsons law states that xn plus 1 is equal to xn minus f of xn all over f prime of xn. Is that clear? So when you find the square root of a positive integer n, remember that the Raphsons law states this. This is the Raphsons law. Now, having said this thing, we are finding the square root of a positive integer n. So we say step 1. We say let x be equal to the square root of n. Is that clear? And so we now begin to square both sides. We square both sides. So x squared is equal to n, because the square root will cancel the 2. And so when you progress from there, you now begin to have x squared minus n is equal to 0. That is an equation. So let's differentiate this equation. With respect to x, you have 2x. Is that not? Okay, now these things, this guy is called f of xn. This guy is called f prime of xn. So let's substitute these things that we just had here now. Let's substitute them back into the equation. If you substitute them back into the equation, you're going to be having xn plus 1 is equal to xn minus. So you're not going to be writing f of xn again. What will you be writing is this equation. You'll be writing x squared minus n over. Now, because everything is carrying the subscript of n. So let's just put n here. Anytime we see x, let's just put n. So 2x, so let's just put n again, so that we can do what? We can collect LCM. So if I collect the LCM of this, how many times will this go in this? 2xn. 2xn multiplied by this, 2xn squared minus. This in this is 1 multiplied by this, x squared n minus n. So you're going to be having 2xn n minus x squared n plus n. Why is it a plus? Why is it a plus? Because minus times minus is a plus. Is that clear now? So we divide it by 2xn. Now, having said all of these things, what I'm going to be having here, now is xn all squared plus n over 2xn. This is how to find the square root of positive integers. Square root of positive integers using Raphsons method. Do you understand? So they can ask this question as it is like this in your test. They said find the positive square root of a positive integer. Do you understand? Now another question that I would like to address is when a student asked me, how do you find the cube root? Now let's assume this one was changed to cubed roots of a positive integer. The same process is applicable. When we say the Raphsons law is xn plus 1 is equal to xn minus f of xn all over f prime of xn, right? F differential. So we now found out that let x be equal to n to the power of 1 over 3. Did you see that? So we are taking the cubed of both sides to the power of 3. To the power of 3. Why? So that this can cancel this. And you have x to the power of 3 is equal to n. And so if you turn this to an equation, this will be equal to 0. So now let's call this guy f of fxn. Do you understand? So now I want to find f prime of xn. If you find f prime of xn with respect to x is 3x squared. 3x squared. We are differentiating only with respect to x. So let's slot in these two things now back into the formula. Insert into the Newton-Raphson formula. So you'll be having xn minus. So what is f of xn now? You have it as this: x to the power of 3 minus n divided by f prime of xn is 3x squared. So at the end of it all, you're going to be having 3x squared. So I told you that because there is a subscript of n, so let's just be putting subscript of n anywhere we see x. So we have 3xn squared. How many times you want go in 3xn squared? Sorry, this is n. Sorry. How many times we want go in 3xn squared? Let's put an n here. We have 3xn squared. Multiplied by this, you have 3xn cubed. Minus, right? How many times will this go in this? We have 1 multiplied by whatever is there, xn plus n. So this is 2xn cubed, right? 2xn cubed plus n divided by 3xn squared. So that is the formula for finding the positive square or the positive cube root. The positive cube root. So let me clean it here. The positive, finding the positive cubed roots of a positive integer n. The answer is using it 2x to the power of 3n plus n over 3x squared. So this is it. Let's not forget. So at the end of the day, you can be asked, okay, haven't gotten this, use it to find the square root of 24 or the cube root of 24. Haven't gotten this, use it to find the cube root of 24. That's 24 to the power of 1 over 3. That's very simple. So you say let your x naught equals to, so what is the cubed root of 24? Let's find that out quickly. So we ask ourselves, what is the cube root of 24? Since we are dealing with 24, what is the cube root of 24? The cube root of 24 is 2.884. So we are picking the whole number only. The whole number only, which is 2. Exactly. We are picking the what? The whole number only, which is what? 2. So you are simply imputing that value here in this function. So we are saying that we are simply saying that 2 into brackets, so x1 is equal to 2 into bracket of 2 all to the power of 3 plus, what is n? Since we are looking for square root of 24, square root of 24, so n is the 24, so plus 24 over 3 into bracket 2 all squared. I believe if you punch that in your calculator, you're going to be having 3.33. Okay, so having said that, sorry, not square root of 24, cube root of 24. Cube root of 24 is 2.88, whatever it is. So x2 will be x2. Okay, this matter is collapsed. x2 will be 2 into bracket 3. So the previous answer is what we are putting in here. 3.333 all squared plus 24 over 3 into bracket 3.33 all squared. So what you're going to be having is, so you calculate answer 2.92942. If you repeat the same process, if you put that same answer inside this function, you have calculate answer. Okay, so 2.845. x4 will be 2. Calculate. So if you calculate this, you're going to be having 2.885. That was a typo error. 2.885. Then if you calculate answer, you're going to be having 2.884. Let's do it until we get to x5. Let's see. 2.8, the same 2.884. So you see, using the Raphsons method is quite better. So the cubed root of 24, according to the Raphsons method, is 2.884. Did you see that? So that is that about Newton-Raphson's method. Please take note of that.